Hi everyone and welcome back. In this video today we're going to talk about Unix and give you a brief overview of why it is that we are interested in using Unix and command line in regards to bioinformatics. So let's start off by just explaining what is Unix. So Unix is a family of operating system that was developed in the 1970s. And the reason why it gained so much popularity and usage is due to its generic interface to many different types of computing hardware. So think of printers, CPUs, memories, and so on. Okay, so we'll wrap it up here for this first video on Unix. And so I know we went over quite a bit with regards to the Unix in the background, but I thought it would be important for you to understand why it is that we're doing command line interface and writing on the command line is a super valuable skill to have. So I'm glad I'm able to introduce this to you guys. And we went over a few different ways to kind of navigate around your local machine, figuring out where different directories and files are located, as well as how to do some basic shell scripting. So as we move further into our data analysis, we'll be returning back onto the command line interface, and at that time we can go into more complex shell scripting. If you guys have any particular requests or things you want to learn about with regards to Unix and shell scripting, please let me know, and I will see you in our next video. All right, bye you guys. It also supports the use of many users running many and different types of programs at the same time. So this allows it to share the transparency on the same computer system. It is also noted to be high programmability. So what this means is that it is a programming environment that allows for more than one script to be composed of functions that are written in multiple programming language. For example, if you wanted to run a loop that uses a text script to be able to input the data into R, retrieve the output from the R program, and then use that as an input for a Python script, you can write all of these different tasks and instructions within a shell script. You might have also heard of Linux. Linux and Unix oftentimes are used interchangeably. Linux itself is a family of open source Unix-like operating system. So what is an operating system? So let's kind of go over the different component of an operating system so that you understand at each level what you're working with. An operating system itself is a system software that manages the computer hardware and the software resources and provides services for computer programs. So if you are using a Windows computer, you're probably used to the Windows operating system. If you're using a MacBook, you've probably heard of the Mac OS. So Unix is another type of operating system. And so operating system has a software called a kernel that resides in the core of that environment. And this kernel is crucial for us to be able to use the computer. So what exactly does the kernel do? Well, the kernel controls how to allocate the different hardware resources to efficiently run the computer. So again, hardware resources can include things such as CPU, memory, different disk storage, but it also includes external or peripheral devices such as network cards or printer. The kernel also provides an environment for you to run programs on the computer. So each time that you execute an application on the kernel, it will facilitate the interaction between the software program and the hardware to ensure that the program can access whatever resource that it needs. So how do programs interact with the kernel to be able to request whatever resources they may need, such as reading a file or communicating over a network Well, that's what's called a system call. A system call are the different software interface that are provided by the kernel, and they're requests that are made by the operating system for different services. So different ways that you can work with a file, for example, opening or closing or reading a file, being able to gain network access, being able to perform different input and output operations. Those are examples of system call. To be able to make these system call, we're going to use what's called a shell. And a shell is a program that allows us to interact with the operating system. So I'm going to be demonstrating shell on a MacBook, so I'll be using what's called terminal. If you are using a Windows computer, the equivalent is the command prompt. So the shell is a program that allows the user to run different applications, execute different commands at a text-based environment. So I'll explain that a little bit further in the next few slides. So the shell again is a user-facing interface, while the kernel, you can think of that as the behind the scene, making everything work. Another layer on top of system call is called the library. And libraries are pre-written code that allows the user to do different common functions. So they are built on top of the system call, and they use the system call to be able to access the different operating system services. As a user, you don't need to worry about the under the hood code of the libraries. You can be able to just access the library to use them on the command line. And the last layer here is the application layer. So these are different programs that allow the user to interact with either a text editor or a web browser. And these applications interact with the operating system by two different ways. The first one is to use directly the system calls. The more common way is to actually use libraries. And this is because libraries are more efficient, they're more portable, and it also allows us to abstract the detail of a system call so that we can focus more on building our actual applications that we're interested in. So as I mentioned, we're going to be using a shell code. So this is a little cartoon by Julia Evans. But this basically shows you how the shell code, you can write your command on the command line, and it allows the kernel to interpret this and tell the computer what to do. So here you're telling it to list the file. So the bash script is going to be the middleman and communicate this with the operating system. And then the operating system is going to be able to then actually run that function. So again, what is a shell script? Well, a shell script, as we mentioned, is a program that's built on top of the kernel that allows for us, the user, to be able to interact with the OS. The shell is going to be on a command line interface. So we'll be using the terminal for the MacBook. And as I mentioned, this is a text-based. So we'll be using command line instruction instead of what we can refer to as a GUI. So you're probably more used to running programs on a graphical user interface, a GUI. So you could think of this as your web browser, where you have like a visualization that allows you to interact with different fields and stuff. The command line is all text-based, and it still allows us to run different services on the operating system, but it's at a command line. So why is this? Well, the reason why we want to learn this is because many of the bioinformatic tools that we will be using does not have a GUI. So we need to interact and be able to run different programs on the command line. So I just want to bring up that there are many different Unix and Linux shells, and these different shells have distinct features, and sometimes they use slightly different syntax. So here I'm listing a bunch of different shells. You don't need to know this in detail. It's just good to be aware that there are many different type of shells because they all have slightly different features to them. So for example, if you want to write shell script, SH is a good one to use. But if you are more interested in making and writing more interactive program, you might want to use CSH. CSH stands for a C style shell, and its syntax is based on the C programming language. So it supports variable, flow control, job control, etc. We will be working mainly with Bash shell, which is pretty compatible with SH. This is a Bourne shell, and it includes features such as command line editing, improved like signal handling. So we would want to use Bash because it's better suited for shell script. So how do you know which shell script you're working with? Well, let's go ahead and open up a terminal so you can go ahead and access it. If you have a MacBook, I have a MacBook, so I'm going to be working with terminal. If you're on a Windows machine, you're going to be opening up your command prompt. And what you're going to type here is echo shell, $shell. And I can see here that I'm working with a Z shell. This is one of the newer shells, and it was created in the 1990s by Paul Fawcett, and it's a Bourne style shell. So it contains the same type of features that you expect to see in a Bash shell, but it has some more features. For example, it actually has the ability to do spell check, the ability to look for login and logout, and some other built-in programs. So returning to the slide, why is it that I am going over Unix and command line interface? Well, it's because a lot of bioinformatic tools do not yet have a GUI. So we're going to use the command line versus in a GUI where you can interact with it and press different buttons and actually access different fields. We're going to be writing different type of shell scripts in order to do a lot of our bioinformatic analysis. Additionally, a lot of these data sets are very large, sequencing data. So while I'm going to be showing you how to do a lot of these analysis on your local machine, oftentimes if you want to do more complex or larger or work with larger data set, you are going to need to work with a computing services. That is, you're going to have to work on what's known as a HPC or high performance computing system. And this means that within that computing system, there are multiple cores and multiple servers so that you can allocate large amount of memories in order to be able to run some of your analysis. Command line also is nice to use once you get comfortable with it because it's actually faster and more efficient. It's easy to do automation. You can run parallel scripts. So imagine if you have a data set that has like, let's say 100 different samples, you can run them in parallel rather than one at a time by being able to write that shell script to be able to automate it. And it takes less memory to be able to run command lines versus a GUI. So these are some of the perks of why it is useful to learn how to use a command line interface. So let's go ahead and reopen our terminal and just get used and comfortable with navigating around it. So here's our terminal. So I am currently located in folder summer MBT, which I made in another video. And so the first thing I want to do just to verify that is to type in pwd. And I find this is super useful because sometimes you don't know where you are in your computer. Like think of it with regards to folders, like which folder am I in? And so this is important because if we have our script in a different folder, then I might not be able to access those scripts if I'm in a different folder. Or if I am in one folder and I have scripts that I need to access certain data files, if I don't know where those data files are located, then how do I write that instruction within my shell script to tell the computer program, like this is where the data is located. So pwd is working directory. So this is the working directory that I'm in. I'm in the December MBT folder. So what is in this folder? What is actually in it is not that important, but I just want to make sure you guys understand how to navigate around. So I'm going to type in ls, and actually let's make this just a little bit bigger. So I'm just going to clear it so we can get back up to the top. So if you type in ls-lah, these are what's called arguments. So I'm typing these arguments in, and I'm asking it to give me the long format as well as like different hidden files. So this will give me more information. So let me just show you the ls by itself so we can compare. So here's ls. ls just lists for me what is in there. So I have something called raw and something called scripts. These are two different directories I created before. So if I do ls-lah, it gives me a little bit more information. So now I can see when these files were created. I can also see who owns it. I can see how much space they are taking on my computer, as well as the different permission. We can go over permission if you guys are interested in a different video, but permissions are important when it comes to you actually sharing your scripts with different people. So this is going to be more important if you were to actually work on a server, right? So there's certain programs or files that maybe you want to make sure that only you have access to them or that you can execute them. So if you're working on a server where multiple people can access those files, you might want to change some of the permission so that not everyone can just read and write and execute on your files. Again, we can go over this again. Just go ahead and let me know, and I can make a separate video if you want to learn a little bit more detail about this topic. So back to what we're going over. So this is the two folders. So if I want to, for example, see what's in the raw file, I can do ls, press tab to autocomplete, and I can see that these are the two files that's in that raw folder. Okay, so let's go ahead and just write a simple script. So vi is a way for us to access the text editor. And so let's write a program called print hello. Right? I feel like this is always something that you kind of start off with whenever you learn any different programming. And shell script you can think of as an actual programming language. So this takes me into my file print hello. So here you can see below, this is the print hello. In order for me to start writing anything in it, I need to press I in order to be able to insert and edit. So I'm going to write what's called a shebang. So it is important for us to have this first line in our shell script. If you do not have that line, then your bash interpreter doesn't know where to find the bash interpreter in order to actually run the bash shell script. So this path that I have following that hashtag and exclamation mark can vary depending on your computer or the system you're working on. Typically it doesn't, but it could. So let's see how to go about finding the path if that is the case. So I'm going to go ahead and press escape, and I'm going to type in WQ. This stands for save my file and quit. So I'm just exiting. We're going to come back to this program in a little bit, but let's just exit. Okay, so I need to know where it is that my bash interpreter is. Like, let's say I wrote this whole script and I execute it, and either I get an error or nothing happens. It might be due to that first line because it doesn't recognize it as a bash script. So in order to know where that bash interpreter is on your particular computer or server, you can type in wish bash. And so this is the pathway to that bash interpreter. So if I go back to my program that I was writing, before I do that, let's actually move this script, since it's a script that we're writing, into the script folder instead of the raw folder. So ls, you can see this is called a print hello. And so let's talk a little bit about moving files and just like how the files are organized. So previously we saw that in the folder we have a raw folder and a script folder, right? That when we ls. So we're going to write this shell script, and I want to put this shell script, let's say, into my actual script folder. So what I can do is I can press, so you could do this two ways. I'm just going to use MV, which is to move the files. If you are new to this and you're still trying to learn how to navigate and write, what I suggest you do is to actually make a copy of that file. And then once you know that your copy file is in the script folder, like the way you want to, you can go back and remove your original print_hello file. For me, I'm just going to go ahead and do MV. So MV is move. So I'm going to tell it to move this print hello file. And I'm going to say move it into this folder. Oops. And I'm going to put a period because a period is kind of like move into this folder here. The period is kind of like pointing down, like this is where I want it to be, here. So if I do that and I press ls again, you can see that it's no longer in that directory that I'm currently in. If I ls script, I can now see that that print hello shell script is in there. Now what happens if I do vi print? It will actually create a brand new print hello shell script. Let's go ahead and just do that just so I can explain to you how you remove a file. You can see that shebang that I had written earlier is gone because this is not the same print hello script that we were working with previously. This is a brand new script. So I'm just going to write this is a different shell script. I'm going to exit, I'm going to save it. So now if I ls in this directory, I have the print hello. And if I want to see the head of it, which is the first few lines of the file, I can see that I wrote, this is a different shell script. Now watch, if I go and I head my script, print hello, right? That's the one that I had moved from earlier. It has the shebang. So these are two different files. So let's just clear this real quick so we can work with a clean slate. ls, the print hello, this is the one that I don't want. This is the wrong file. This is a different file. So to remove it, and keep in mind with shell script, you can't easily undo if you remove a file, which is why I suggest that if you're new to this, perhaps you want to make a copy, make sure it's actually put in the folder and directory that you want, and then go back and delete it. Just because once you remove the file, that's it. You can't recover it as easily as you would if you're used to working on your Mac OS, for example. It usually gets moved into the trash folder. That isn't the same on Unix, right? So once you delete something, it's goodbye, which is why in another video I recommended that if you have raw data files, that you make sure that you have a way to organize it. So here I put it into raw, that you have a way to organize it so that it doesn't get touched, so that you don't accidentally delete it, that you don't accidentally overwrite it, because once you do that on the Unix, that's one of the downfall of Unix. On the Unix, that's it. You can't recover it the same way. Okay, so back to where we were going. So I know that I don't want this print hello file. So I'm going to say rm for remove, print hello, and it's going to remove that file. So now if I list, that file is gone. However, the file that's in my script folder that I want to keep is still there. So let's go cd into the script folder, cd change directory into that folder right there. And let's go ahead and use the text editor to reopen that file again. So here's that. And so let's go ahead and start writing a very simple shell script. Unlike if I was in a typical GUI program, I can use my mouse, right? But in VI and Unix, you can't just use your mouse to move around, so you actually have to use your arrow. There are a few shortcuts they can use. So right now you can see I'm not in the insert mode. Let me press I again, and you can see that is the insert mode, which means I can type. If I press escape, it takes me out of the insert mode into normal mode. And from here, if I want to go to the end of the line, I can use the $sign, and it'll take me to the end of the line. If I want to go to the beginning of the line, I can enter 0, and it'll take me to the beginning. So let's go to the end of the line, and now I'm going to hit insert, and I can start typing and moving on to the next line. You can also, if you don't want to have to insert and escape in order to be able to type the next line, let's just type in a comment. The comment starts with a hashtag. This is a comment. I'm going to escape. I'm going to type 0, and this should take me to the beginning of the line. So what I was getting at is, let's say I want to get to the end of the line, but I want to go straight into a insert mode. I can, in escape, type in capital A, and that will take me to the end line and put me in insert mode. So this is a comment. So let's write a simple shell script that basically says hello world when we run the shell script. So we're going to type in echo hello MBT. So when I exit this and I run a shell script, what it's going to do is it's going to go through the first line, recognize as a shell script because it points to the bash interpreter, and then it's going to iterate through each line. It's going to go through first line, there's nothing. Second line, it sees that there's a comment, so it doesn't execute anything. Third line is going to read this command, and this is the same as if you wrote it on the command line itself. So it's going to read this instruction, and it's going to echo back to us on the terminal, hello MBT world. So let's go ahead and exit this. So we're going to press escape, and we're going to save it and quit. So WQ, and if I want to run it, I'm going to say bash, and I'm going to run it. Bash print hello world. So it should echo back for me, hello MBT world. So that's it. You just wrote your first simple shell script. So let's do a few more things and we will wrap up this video. So let's go back to our print hello shell script, and let's say that you want to work with variables. So I'm just going to introduce a few little things. So a variable is basically like a placeholder for a certain value or for data that can be changed during program execution. So here, let's make our variable an echo. So we'll say, I'm going to write a quick comment. So, working with variables. So let's say our variable is a greeting. Greeting will be welcome that'll be our greeting. And let's say our other variable is name. So we'll say group equals. So now we can echo and we can call the variable and let's go ahead and escape and run this and see what happens. So if we bash, oh, one thing I didn't go over is the reason why you can see it just flashing up is I'm actually using the arrow. So if you use the arrow key down or up, it will take you to the previous command that you had written. So I press up to get back to my previous command. So I'm going to run this again. And you can see now it says hello MBT world. That was the first set of code scripts that we wrote. And then welcome to this YouTube video, which is the second set of script, right? So let's go back. So I press up twice to get back to this command line. And let's do one more thing. So I'm going to add one more, which is, let's say, we'll make a comment of getting input. So let's use the same greeting, but now we're going to want to ask people for their name, for example. So let's go ahead and ask people for their name. So I'm going to echo, what is your name? And next, I want to prompt the user to input their name. So what I can do is type in re, and I'm going to store whatever they type in into your name. That's going to be my variable name. And now we're going to echo that greeting. Okay, so let's go ahead, exit and quit and save. And let's run that. And you can see there's the prompt that says, what is your name? So I'm going to put in Jessica. Enter. It now read in, stored that prompt or stored that value into the variable your name, and then printed out the greeting with that variable in this place. So welcome to this YouTube video, Jessica. Okay, so let's go ahead and stop there.